So hello guys, today we are going to discuss really hard problem which was asked in online assessment of CodeNation just in February 2023. That's what I feel. So before discussing this problem guys, this problem requires lots of prerequisites, okay? A person should be having fair amount of good knowledge of dynamic programming, of bit manipulation, etc., etc. In case you don't have knowledge of those topics, then please check my playlists on bit manipulation and DP. If you watch them, then surely you will be able to solve this problem, or at least understand what I'm going to teach, okay? All like the link to the problem, everything else, thoughts, ideas, link to the playlist, everything will be in the description. Apart from that, if you guys are interested in cracking top level companies, good companies off campus, then you guys can join my mentoring plus training programs of 8 months, wherein I mentor and train for DSA, Dev, LLD, CS fundamentals, job support, and referral support for continuously 8 months till the students get successful. Now, coming back to the problem, what is the problem saying? The problem is saying that you are given an array of size n and an integer k. You have to partition the array into k subarrays, okay? K contiguous subarrays such that the sum of bitwise OR of all the subarrays is maximized and each element should belong to a partition. Okay. So for example, they are saying us, let's say we are given this array, okay? We are given this array wherein. Okay. So let's just assume we are given an array like this: one, two, three, four. Okay. So the task n, the size of array is 4 and the k is 2. It means you have to divide this array into two parts such that the sum of bitwise OR of those two parts is as maximum as possible. Okay. So say you divide something like this: first part, second part, answer of this part is k1, answer of this part is k2. Question is saying that k1 plus k2 should be maximum, okay? So for example, say I had one, two, three, four. One way is that first part, one way is that I take 1 in the first part and 2, 3, 4 in the second part. What will be the bitwise OR of 1? It will be 1. What will be the bitwise OR of 2, 3, and 4? We can check that in the example. It is given as 7. So this is 7. So what do we get? What is the answer? 1 plus 7, 8. I hope you guys know the meaning of bitwise OR. Okay now. So after doing bitwise OR of 2, 3, 4, I got 7, and 1 is the only number, so nothing to do. So 1 plus 7, 8. Other method is that I take the first two numbers. Okay. So bitwise OR of the first two numbers is what? It's given here. Bitwise OR of 1 and 2 is 3, and 3 and 4 is 7. So answer is 10. There is one more way. There is one more way in which you take the first three numbers in the first part and the last number in the last part. So the answer will be, this will remain 4 only as nothing is there. And the OR of 1 to 3 is nothing but 3. So it will come out to be 7. So this gives 8, this gives 7, this gives 10. We have to print the maximum answer. We have to print the maximum answer. So maximum is 10, so 10 is our answer for this problem. For n equal to 4, this was the array, and k equal to 2 means you have to divide the array into k parts. So let's first write the first observation. Don't worry, the link to this document will also be in the description below. I think I'm using some other email ID. So such a nice day. We are given we are given an array of size n. We have to divide the array into k continuous parts such that the sum of bitwise OR of each part is as maximum as possible. As maximum as possible. Okay. So we already saw the example that if we have this thing like 1, 2, 3, 4, and we have to divide it into two parts, then the answer is nothing but 10. Okay, answer is nothing but 10. So let's think how can we solve this problem. Okay, let's think what can we do. So I think we have the problem with us. Yeah. Let's see the constraint. The maximum value of n can be 1000 and ai. Okay, n will always be less than equal to 1000. Okay, the size of the array, and a of I, each element of the array will always be less than equal to 10 raised to 5, greater than equal to 1. Okay, this problem is like based on the memory of the students, so that's why we couldn't find the exact pic because the test was proctored and we are not allowed to take images of the problem. Okay, so no worries. Anyways, so we have the right solution for this. Don't worry. So guys, what we can do is the first solution is the DP one. Okay, like intuitive DP. Whatever we are feeling, we will write, and that's our solution. Intuitive DP. Okay. So guys, what can we do? Let's start thinking. What can we do? What can we do? Guys, as explained in my previous 15 to 20 DP videos, always we first should make an empty DP array and then think about it. Think about its definition. For example, say I had this array starting at index 1 until index n. Then what did I taught in the previous video that if you are at index I, just make an empty DP array of same size n. Just assume that DP of I should give answer to the question if the size of array was I. Okay, so just rough idea. DP of I gives the answer to question if we consider only first I elements. Okay, but guys, we need to try to feel something. We need to try to feel something here. We need to try to feel something. The thing is, there are many elements in the array. But say you have to divide the array into two parts or say k parts. You will divide something like this, right? Part 1, then part 2, right? Say this is the index I. So basically when you are at index I, you need to check for each type of part you can make at the end. Okay, this one, this one, this one, this one. So it is better to have a state dpi comma j. Okay, dpi comma j. dpi comma j, because we are having two variables. One, the array size is increasing, and the second thing is the number of paths. Okay, we need to like increment the number of paths. Only then we will be able to calculate the current dpij values from the smaller dpij values, right guys? So the thing is that let's define a function like this, dpij. This means the best answer to our question if if we are dividing the array of size I into j paths. Okay, so now let's try to calculate what should be the dp values in our array. Okay, so guys, let's say I had this 1 2 3 4. Okay guys, what would be the value of dp1 of 1? dp1 of 1 means only considering the first element and dividing it into one part. There is nothing to do because there is only one element, so 1. What would be dp2 of 1? It means answer for array 1 comma 2 such that we divide it in one part, which means no division. One part is the same part, you don't need to divide, which means no division. So best answer is 1 or 2. 1 bitwise or 2, which is 3. dp2 of 1 is nothing but 3. Now guys, someone came to you and asked you, what is dp2 of 2? It means best answer for array such that it divide it in two non-empty parts. There is only one way to do it. This. Okay. First part will be 1 and the second part will be 2. This will give us what? 1 plus 2 equals to 3. When there is only one number, you don't need to do any bitwise or, guys. Now, now let's say if we were asked dp3 of 1, it means best answer for array 1 comma 2 comma 3 such that divide it in one part. So if you are only dividing in one part, answer is 1 or 2 or 3, 7. What is the answer for dp of 3 of 2? Now you have the choice to divide this into two parts. You can either option 1, you can either do 1 plus 2 or 3, or option 2, 1 or 2, you take this in the first part and 3 remains like this. So answer is maximum of option 1 and 2. Similarly, if someone asks you dp4 of say 3, you have three options. Three options. You have many options, okay? Many options. Let's take a easier case. dp4 of 2. Which is option 1, guys? Option 1 is 1 plus 2 or 3 or 4. Option 2, 1 or 2 plus 3 or 4. Option 3, 1 or 2 or 3 plus 4. This gives us 7, this gives us 10, this gives us 8. So whichever is the maximum of three option is answer. It's 10. Guys, I hope you guys understood what is the meaning of the DP state I am trying to say. So guys, now let's take a 1 minute break, guys. Some chimpanzees in the room, guys. Okay. Always remember, in DP problems, na, the meaning of the state should be very clear. Okay. So see, first I discussed DPI, then I advanced the stage depending on the requirement. So DPIJ is nothing but the best answer to our question if we are dividing the array of size I into j paths. Okay. Now guys, let's think of the transitions you can do. Okay, transitions, the formula. So So, say you are given this array like this. You are at index I. How will you calculate dpij? You have so many options. You want to divide the array of size I into j paths. So what is the option 1? Option 1 is take this one element and add the best answer of the rest of the part. So this one element is what? A of I or B of I. So option 1 is A of I plus dp of, obviously the index before I will be I minus 1, right? So dp of I minus 1 and j minus 1. Why j minus 1? You are trying to divide it into, say j was 5. You are trying to divide it into 5 parts. Now you took the last element in the last part. So now you should divide the leftover array in 4 parts. That's why I'm writing j minus 1. Okay, this is option 1. Like this, what will be the option 2? You can take the last two elements. You take the last two elements in the last part. A of I or A of I minus 1 plus dp of I minus 2 j minus 1. Let me explain it in a much more easier manner. Okay, I am a fan of taking breaks. Let's say you want to calculate dp of 4 of 2. You want to divide this array into two parts. What is the option 1? Put 4 in the last part. Then the answer would be what? dp of 3 of 1 means dividing this much into one part plus the second part, which is 4. This is option number 1. What would be the option number 2? You can take these two numbers in the last part. So option 2 is dp of only this much part, dp of 2, dividing this in one part only, this much, plus taking the last two elements in the last part, which is 3 or 4. Then there is option 3, which is taking the 2, 3, 4 in the last part and the first one in the first part. So it will be dp of 1 plus 2 or 3 or 4. I hope you guys understood what I'm trying to convey. Okay. Now let's write the general formula of dp of I of j in the document and then we'll go ahead. Okay. dp I of j, option 1. Take last element at index I in last part of the J paths. So the answer will be dp of I minus 1 j minus 1 plus e of I. Let's consider it was array B. Okay. This is the option 2. Take last two elements at index I and I minus 1 in last part of the K paths. So the answer is dp of j minus 2 j minus 1. I hope you guys understood why we are doing j minus 1. Okay. Plus e of I minus 1 or b of I. Similarly, option 3. There are so many options. It will be dp of I minus 3, like taking the last three elements in the last part, j minus 1. J minus 1 remains the same because once you have divided the last part, then only j minus 1 parts you need to do for the leftover prefix part. Okay. So prefix means starting part of the array plus prefix means starting part of array. So plus b of I minus 2 or b of I minus 1 or b of I. Like this, we have n options, many options. Okay, in general, take maximum of all options. That is your answer for dpi of j. Okay, so what will be the algorithm? We will have to run three nested for loops. Three nested for loops. Calculate dpij for all I from 1 to n because there are n elements, and all j from 1 to k because they want us to divide the array into k paths. So two loops will be taken for this only, 1 to n and 1 to k. Third loop will be needed for calculating these options. Okay. First option, second options. There can be n options. So n into n into n. One for loop will be of I going from 1 to n. One for loop will be of j going from 1 to k. Or you can say 2 to k. Whatever. Okay. So now here I have to calculate dp of I of j. Now dp of I of j is also a bit complicated. You have to try all possible paths. So int ij, int part. So int part, first you will try the last part. Okay. Last part, which is nothing but at index I. Then you keep on calculating this while part greater than equal to j. You know, part minus minus. Basically, first you are trying to calculate for say you are at index I. First you calculate this as the last part, option 1. Then this as the last part. Then this as the last part. That's why I'm declaring last part as I, and I'm writing while last greater than equal to j. If you want say j was 2, so you should only try till here. Why? only till here 1 2. Why? Because if you are taking this full part in the last part, then only one will be remaining. Oh, then only you can divide it into two parts, right? Because j indicates the number of paths. That's why you should like last should start from index I. It should start decreasing, but it should only go till j. Okay. For example, say j was 3. So first, while calculating dpij, your last will start from 5 and only go till 3. Why? One option is this. Okay. You take this in the last part. Other option is this. And the last option is this. You cannot go ahead and then that. Why? Because you are forced to divide this into two parts. And this can only be divided. The last part is only one part. So total will be three parts. And J was 3. So we wanted to divide this array into three parts. If you go till here, say you come and say, bro, I will take this in the last part. Okay, no problem. This is one part. Now how can you divide this remaining one into two parts? You need total three parts, na? That's why you start the last at index I and only go till index j. So it takes three nested for loops. Okay. So the time complexity is O of n cube. While path greater than equal to j, keep calculating. Max of dpij or of all the numbers from index I to last from I to current part plus dp of path minus 1 j minus 1, because you're taking everything from path minus 1, right? Say if this was your part index when you are calculating, so or of all these numbers and dp of all the numbers till part minus 1, so dp of part minus 1 j minus 1. J minus 1 means j minus 1 parts. You know the best answer to divide this much part into j minus 1 parts, and here you're calculating the or and adding one more part to j minus 1, which will make j parts and give you the best answer of dp of I of j. It will take three for loops. Time complexity will be O of n cube. Space will be O of n square. As we declare, dp array. Here two dimensions, right? dp n and n array. So n square. O of n cube is not very efficient, right? N is 10 raised to 3000. So n cube will be what? 10 raised to 9, which will give time limit error. So we need to find better algorithm. Although this algorithm will give partial marks. How to get a job at CodeNation? You need to solve this problem. Think, guys, think. I'm giving some time. We did the DP in this problem, okay? But can you see we forgot to use one thing, which is bit manipulation. If we use bit manipulation, obviously we can get a better answer. So start thinking about it. Let's take some break. This is my website, guys. I get 1 to 2 to 5 lakh visitors every day. You guys should try to visit this website and use it for the job opportunities, coding questions, problems, answers, some news, etc. My team is doing a fantastic job on this. So, anyways, mm, hmm, guys can also enroll in my mentoring program. Everything is given here. Some person is still reading. Good, good for the market. Anyways, let's get back to the problem. So now, you guys, can you guys realize that we are taking extra time? We are taking extra time to calculate the last for loop. Meanwhile, the code for the first problem is here. Okay, for the first algorithm, this is the code. See three for loops and calculate the answer. DPNK will be the final answer. DPNK का मतलब क्या है? For the array of size n, the best answer to divide them into k paths such that the answer is maximum. So guys, my first observation is that we are taking extra time to calculate the answer for the last for loop. Okay. So this for loop we should try to reduce. The main observe one more observation is that is bitwise or of a range only changes for maximum 20 times. I will explain this why. So guys, let's just chillax, fully chillax. Our all our numbers are less than equal to all our numbers. All our numbers are less than equal to 10 raised to 5. Okay, okay. All our numbers are less than equal to 10 raised to 5. So all our numbers are less than equal to 10 raised to 5. So they will have maximum 20 bits. They will have maximum 20 bits in their binary representation. If you don't understand what I'm saying, you should please watch my bit manipulation playlist given in the description. I've taught things there from a beginner level. So they will have maximum 20 bits in their binary representation. So what I mean to say is, let's say we take a universe where we are having 5 bits of each number, okay? So say something like this. Okay. Okay. So guys, the proposition is that the suffix or will only change 5 times. In this case, will only change 5 times. Why? Because in the bitwise or, if 1 times 1 start coming, then the suffix value will always be 1. Okay. So here the value is 0 1 0 0. Okay, first. Now when this comes, the value changes. Here when we reach here, the see here first when the value changes I am writing as C. When the value doesn't change I am writing as NC. So here the value changes of the OR because we are calculating the OR from the back part of the array. You remember you guys? In the last for loop, here you're calculating bitwise OR for from the index I, right? First you're calculating for this much part, then you're calculating for this much part, then you're calculating for this much part. So whenever the bitwise OR will change, I will write C. If it doesn't change, I will write NC. So here it changes, here it changes. Here it doesn't changes because one was there here also. So it NC. Here also it doesn't change. NC. Here also it doesn't change. NC. Here it changes C. Here it changes C. Here it changes C. Here it changes not NC. Guys, can you see the number of C? 1, 2, 3, 4, 5. So suffix or changes for only 5 times. If each number can be represented by 5 bits. No matter how long the array is. Say the array, this was index number 1 and this is say 1000. Even then, the suffix or will only change 5 times. For example, I can show you guys the proof if you want. Let's say all the numbers 2 raised to 5, right guys? So 2 raised to 3 is 8. And 2 raised to 4, 1632. Let's say we put all the numbers from 1 to 32 again and again in this array of size 1000. Then I start doing suffix or. It will change for only 5 times. Change for only 5 times. Why is it changing for 5 times? Because whenever a 1 comes, whenever a 1 comes, it stays 1 forever. So basically, say we had only 2 bits like this, 0 0 0 1 0 0 0 0. What would be the suffix or? 0 0. Then now 1 came, it will remain like this. What will be the suffix or? 1 will remain like this. So no matter how large is this, no matter how large is this, unique bitwise or can only come 2 times. One is the one here and one is the one above. So there will be only 2 places of uniqueness. Okay, one is here and one if it comes in future. So if there are 2 bits of number, then 2 times. 5 bits, 5 times. Each of our number is less than equal to 10 raised to 5 in the array. In the number of 10 raised to 5, we only require 20 bits. It means the bitwise OR will be changed only 20 times. So now calculating things got easier. Say you have this array. We know that this can happen only 20 times. But let's assume a smaller number. Let's say this can happen only 5 times. So you are at index I. You know that bitwise OR from here to here is same. Okay, because it changes only 5 times. It is K1 here. From here to here, it is K2. From here to here, it is K3. From here to here, it is K4. Here to here, it is K5. So what you can do? Only five options are there now. Initially we were calculating n options. Now we have to calculate only five options. So it will reduce our time complexity to O of n square into phi. So say you know that this part has k2 as the answer. So what you can do is you can take the first element of k2 and put this in the last part. The answer will be what? Say this index is y. Answer will be what? Or of all numbers from y to that which is k2. K2 plus dp of y minus 1 j minus 1. Even if you take a number here, the answer will be same. K2 plus dp of whichever index is here minus 1 j minus 1. But I am taking the last index because I want the dp to be maximum as possible. So if I give more space to the dp part, it will become maximum. No need to give more space for this because this remains same. Explaining with an easy example. Let's suppose this is the array, guys. I minus 1. Let's say the value changes for only two times. Here the suffix or was phi, it can only increase, okay? Then it becomes 8, like this. So you only have to calculate for two values, okay? One option is this one and the other option is this one. Instead of calculating for n options, now you have to calculate only for two options. So, so the first option will be this one, which is phi plus dp of I minus 1 j minus 1. Other option will be this one. Let's say this index is y. Let's say this index is y. Answer will be 8 plus dp of y minus 1 j minus 1. Means this much part you are saying dp will calculate this much and this much, or you already know it is 8. It is given here. Why am I taking the first value? When 8 come, I was focusing on the first time when it become 8. When I was looking at 5, I focused on the first time it become 5. Why? Because no matter what other value I take, it will always remain 5. So it is better to take the first value so this part becomes large. If this become large, dpij gets the chance to increase. Okay. In your answer is what? Or of previous numbers plus dpy minus 1 j minus 1. Now this remains constant, okay, for some part. So it is common sense that you should take largest y possible. That's why I'm taking the first occurrence. Largest y possible to increase the chances of it being the largest answer. I hope you guys understood this much. So how will we calculate these paths? Guys, very easy. Let's say there are only 5 bits. Bit 1, 0, 2, 3, 4. Okay. So you just need to know when was the last time the 0 bit got active. Okay. So say the 0 bit got active on index y. It means the first time a change happened here. So the option 1 will be what? K1 plus dp of y1 minus 1 j minus 1. Now the closest point where the first bit became 1 to this index, say it is y2. Answer will be K2 plus dp of y2 minus 1 j minus 1. Like this I calculate for K3, K4, K5, and maximum of all this is my answer. I am considering only 5 to not confuse you guys. In reality there are 20 bits to consider. Okay, let's go to the code to make these things more clear. Now you guys must be saying, Bhaiya, why are you doing like this? It's very easy, guys. It's good. It's very easy. Okay, let's go to the code. So everything remains the same, but I've created this check array, check array of size 25. So for the first number, I check if any bit from 0 to 18, because 0 to 18 or 0 to 20, whatever you can take, because 10 raised to 5 is enough for 18 as well. So any bit from 18 to 0, okay, if it is getting illuminated, I am putting it as check of I equal to 1, because I'm checking for the first number. Okay, same first for loop, then the second for loop, and here I am doing the pre-calculation of suffix or. Okay now, because I will be needing it while calculating this k1, k2, k3, k4. For this I am using the suffix or concept. Okay, so pre-calculation of all suffix or, then our normal j loop. Okay, earlier we were trying all the paths. Now we only check at most 20 paths. Okay, I go from 0 to 18. I find the recent index where it got illuminated. Okay, and the answer is what? Dp of index minus 1, y1 minus 1, j minus 1 plus o of index, which gives me the or value. O of idx gives or or of numbers from p of idx from idx to I. How do we calculate this? Because I'm using this pre-calculation array here. Okay, so we run 18 steps here. Okay, calculate the max, the answer. That's it, guys. Too much tired. Now let me relax, guys. Take care. I have to mentor students, handle website, take care of so many things, guys, and do the job as well. So many things. Handle the job formalities and all. Anyways, let me stop this video. Hope you guys enjoyed it. Please, guys, subscribe. Okay, increase the number of subscribers. I don't like to do that YouTube thing, but still. Now let me stop the recording and